everyone. Uh, I'm Sajjad, and today we're going to do a live stream on the third problem of the series 100 Problems of Leetcode. I don't know how many people are online now, but hope we have enough visitors to actually share our experience with them. Today's format will be a little different, and I would explain along the way that's what differs from the previous shots that we had. Okay, so let's read the chats and see if anybody is actually on the chat sections. Unfortunately, there's no chats right now. Is anybody on? If yes, please write something in the chat section. Can you hear me? Okay, we will wait a few more minutes, I believe. Then. So, nobody in the chat. Then let's wait another few minutes and then do our thing. Why not? Okay, I don't know what's going on, but we have only one person in the chat already. Okay. Then let's just update the bitrate, maybe the output would help. Recommendation is 23,500. I hope it becomes smoother. But yes, okay. So today we're going to, unlike the previous episodes, we're going to solve a problem from a blog that I found, and the blog is actually some 60 random problems, but they are separated by topic. So we could start going through them, and they mentioned that these 60 Leetcode problems are good for the coding interview, so maybe we could get something out of this if we continue to do more purposeful selections of problems. I thought that maybe we could start with the most top one, linked list cycles. So let's check it out without further ado. Okay, so this is the problem, and let's read it. The problem says, given head, the head of linked list, determining if the linked list has a cycle in it, there's a cycle in a linked list. If there is some node in the linked list that can be reached again by continuously following the next pointer. Internally, pose is used to denote the index of the node that tails next. Pointer is connected to. Note that pose is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So, for example, we have 3 is linked to 2, 2 is linked to 0, 0 is linked to -4, and -4 is linked to 2 again. So now we have a cycle. Okay. In this example, there's an array 3, 2, 0, -4, and the position 1 has a cycle. So it's true. There's a cycle in the linked list where the tail connects to the first node, 0th index. Okay. So in the second example, 1 links to 2, 2 links to 1 again. And we have another cycle, but this time at position 0 of the array. Sorry. There's a cycle in the linked list where the tail connected to the 0th node. And last but not least, if the array is 1, we don't have any, it's not an array, the linked list is of the length 1. We don't have any actual cycles in it. So this time let's read the problem until the end. The number of the nodes in this list is ranged from 0 to 10 to the power of 4, so it's like 10,000 nodes, and the value is going to be from 10 to the power of 5 minus 10 to the power of 5 to 10 to the power of 5. Okay, and -1 is valid index for the linked list. Okay, so there's a follow-up. Can you solve it using O1? Okay, and it's an easy problem. So, just to explain what a linked list is. A linked list is a node, and a variable, a complex structured variable, which has a single value in it, or a complex model of value in it, and links to the next or the previous node. We have double linked list if we have both next and previous, and we have a single linked list if we have just next. So based on that, the linked list, let's go to the thing that we have here, is definition for single linked list. As the problem said, it's a single linked list because it's only referring to the next. We choose TypeScript as our programming language, as always, here. And as you can see, we have value. As I mentioned, there's usually a value in the structure of the node in the linked list. Then we have the next link in the linked list. The constructor of it gets the next link plus the value, and the next link could be null, meaning that it is either only one node or the last node, which makes sense because they're both the same. So, and we are setting them. Now we have a has cycle function. Okay, so The way I see it personally is that we have to traverse the linked list and see whether we are seeing a duplicate node in our linked list, right? Traversing a linked list is simple. We create a current pointer, then we continue going to the next, and the current moves forward. But as we go forward, we want to find all the nodes stored, all the nodes that we have so far somehow marked. And if we get to a place that is not already marked, we move forward. If we get to a place that is already marked, we know we have fallen into a cycle. And the complexity of this would be, as it says, between 0 to 10 to the power of 4. So it makes total sense to do it. Okay, let's start coding and see what we're up to. So we will have a current which would be the head. Head is the pointer to the first item in the linked list. And as we know, it's an object, and objects in TypeScript and JavaScript are pointers. So until, and we know that the last item is going to be null. Until we have not reached null yet, we want the current item to be current dot next. Easy enough, right? This goes the entire way. So this is how we traverse a normal linked list. But as we said, we want scene nodes, which would be a new map of a list node to a boolean, for example. Why I'm saying this? Because I don't have an indicator of whether or not we have seen something. We don't have a signature for the node. I'm just going to store the list node as a key in the map. And a map is a data structure like a dictionary which maps something to something else. So if it is actually in the map, I can assume that we have seen it before. That was the solution that we thought of initially. So basically what we're going to have is, before going forward or after going forward, okay, first we're going to, we're in new node and we are sure that we haven't inserted that in. So we can say if it has the current, then we are sure it has our cycle in it. Otherwise, we don't know. So we set it. You know why I didn't set it before actually reading it? Because it didn't make sense. If we set it, then we obviously had it in the map. So first we check to make sure that it's not in the map. If it is, we didn't insert it. Somebody else has done it, so true. Otherwise, we go further. This while goes until we reach at the end, and at the end, we return that false, meaning that we have not seen any nodes being repeated, so we don't have any cycle. Let's run the code and see what we get. Okay, so I missed a parenthesis here. We have to close. Okay. Okay, so it's saying that what are you setting here, and obviously I'm setting true, and running the code once more. In the meanwhile, let's read the chats. Okay, seems like we don't have any chats. So let's get back to our solutions then. Oh, it got accepted. So let's insert new test cases. The other two that were in the problem. So it was 1 and 2, and we expected 0. And there was 1, and we expected -1. So let's run the code again. Okay, seems like it's accepting all the test cases. And let's submit it and make sure that we get the right result. And yes, okay, we got it accepted. So let's explain what we did. We went through the items in the array, and by going through the items in the array, in the linked list, we added them one by one to a map. So let's show it in the code. We added them, we went through by setting a current, then going forward. We added them one by one to the map. And if there was, we are adding them to the map. If there was something in the map before we added it, we definitely have reached a cycle, and therefore we have somehow found a cycle, and we would return it. Otherwise, we just move forward. But there was something else written in the statement of the problem. Let's check that as well. First, let's see again. Maybe we have something in the chat. Nope, I don't see at least anything. I don't know why I'm hearing something. Okay. Do the people in the chat still hear me? I'm going to move forward to the second part, which would be this part. Can you solve this in O1 memory? So what we did is we got a map, and a map is for sure an array, something as the size of the linked list, if not bigger, which is bigger because we have a boolean attached to it, and we know the map has additional data stored in it that makes it efficient to retrieve. So can we solve it without using a map? Unfortunately, guys, I can't see the chat. I don't know why. I'm hearing chat stuff, but I'm not actually seeing. Okay, so yes, you can still hear and see me. Cool. Going forward, can we solve it more efficiently? I think we can. And it's due to the size. Okay. So the size is limited, right? If we hypothetically get in a loop, then we could count how many items we went forward. If it's more than the range that they have gave us, then we're in a loop. Makes sense. Because we know that a loop would contain a limited set of items. In the linked list, we would have limited set of items, and in a loop, if we continue to go, we will go infinitely, so we could traverse without a risk. And if we're going one step more, then obviously we have gotten stuck in the loop. So let's comment this out and see what this new solution would be. I don't know why, but unfortunately I couldn't see your chats. I hear something, so sorry if I'm not answering to anything. Okay, so let's get back to the solution. I commented out the first solution, which we got accepted. Now my new theory is we're not going to use a map, so we're going to do a counter equals 0. I hypothesized if we get in a loop, then the counter would go on and on and on, and we would exceed the maximum number of elements that the problem has gave us. So still we are going to have a current that is the head, and while the current is not null, we will traverse the linked list. So the current would be current next, but this time if count is greater than 10,001, the problem has said the maximum times it is, then surely we are in a loop. Otherwise, we get out of the while loop before and we succeed, but we have to make sure that we are actually adding the counter. So it's a counter. Let's run the code. Okay, it got all those cases. Let's submit it. And yes, success. So to explain this solution, there was just a simple hypothesis that loops are infinitely repeated if you traverse a linked list with a loop. So obviously we know that the maximum elements in a linked list would be a finite amount, which is 10,000, as the problem says. So if I start traversing the loop, traversing the linked list, and figure out that I have went more than this amount, obviously I'm stuck in a loop, and it worked. So tonight we approached the problem and solved it with 2 different approaches, and hope you enjoyed it. Thanks for being there.